Hello, in this video we're going to review some of the terminologies about graphs. So we're going to see this example here. It says, for each of the following characteristics, draw a graph or explain why such a graph does not exist. So for A, we want 4 nodes of degree 1, 2, 3, 4 respectively. And for B, we want a simple 4 nodes of degree 1, 2, 3, 4 respectively. C, 4 nodes with degree 2, 3, 3, and 4 respectively. And then for D, we want 4 nodes of degree 2, 3, 3, and 3 respectively. So I would like you to stop the video and try to draw these graphs. So for A, we have 4 nodes. Here is 1, 2, 3, and 4. So let's see, we want degree 1, 2, 3, 4 respectively. So let's do the node 1 with 1 degree. So maybe 1 can go to 2. And the node 2 with 2 degrees. So maybe we'll go to 4. And then now 2 has 2 degrees and 1 has 1 degree. And then 3, we want it to be 3 degrees. So how you do that? So maybe we connect with 4. And then make a loop, and that will give you 3 degrees. And then for 4, now 4 has 2 degrees, and to add 2 more, maybe we make a loop. Because right here they didn't tell us a simple graph, and just say a graph. So simple graph should have no parallel lines and no loops. And so for B, what we want is a simple graph. That means no nodes, no parallel lines. No parallel arcs. 4 nodes with degree 1, 2, 3, 4 respectively. So let's draw again 1, 2, 3, 4 nodes. So what we want? We don't want no loop, no parallel line, and the same as before. As you see, this can be will be impossible. So we can do this. If you try, not possible. So for C, we have 4 nodes again of degree 1, 2, 3, 3, 4 respectively. So let's draw this. And again, we want, maybe this one will make it 2 degrees. So let's go here. Here is 2 degrees. This node here, we want it to be 3 degrees. So maybe we'll go here and then 1 more here. So let's do this one 3 degrees as well. So here. And this one 4 degrees, so here 4 degrees. We made the loop to make it 4 degrees. Because again, they didn't say simple. And for D, let's see. We want 4 nodes of degree 2, 3, 3, and 3 respectively. So we see that this is impossible. Is that if you count all the degrees, we have 2 plus 3 plus 3 plus 3, we get 11 degrees. But the sum of all degrees must be even, not odd. So the sum of all degrees must be even. And that's why impossible. So this one is impossible to draw based on this given information. Okay, so here we review the simple graph and degrees. So now let's see, what is bipartite complete graph? Here is the definition. So the bipartite complete graph is a graph can be partitioned into 2 disjoint non-empty set and 1 an empty. So basically we need 2 set of nodes. So the set 1, each node is connected with every node in the set 2. So as we call it N1 and N2 if you want. So, and then how we write it? We write it as Km, comma, N. Or for this one here, this is basically K, 2, 3. So 2 nodes connected with the other 3 nodes. So these bipartite are usually used in social networking analysis and train schedule sometimes as well. So for example, this group of people are friends, so we try to connect them with the other group who are friends, like they do in Facebook and so on. So here is a simple example here. We need to draw K3, 4. So 1, 2, 3. And then the other set is 4. So 4, 5, 6, 7. And then you connect every node with every other node in the set. And this is K3, 4. So this bipartite is just terminology. You need to know what is this graph, because we're going to use it later when we talk about planar or non-planar graph in a theorem called Kuratowski theorem. So this example here, we have an acquaintanceship graph, is an undirected graph in which the nodes represent people and nodes A and B are adjacent if A and B are acquainted. So for example, Carl and Ivan are acquainted. The acquaintanceship graph for the IT department and the marketing department of a major corporation is an unconnected graph. What does this imply if it is unconnected graph? So if everyone in the department presumably knows everyone in the same department, this would mean that no one in the IT department knows everyone in the marketing department and vice versa. And for B, the following figure here represents an acquaintanceship graph for a resident of an apartment building. So now the question, are Carl and Fletcher acquainted? Here is Carl and here is Fletcher. There is Ivan between them. Or you could go this route, Moku, Yuri, and then Fletcher. So what can we say? Carl and Fletcher not adjacent, and therefore Carl and Fletcher not acquainted. And for the second part of the question, C, Ying is acquainted only with Carl. So the last question, question C, the length of the shortest path between node A and B is an acquaintanceship graph, is sometimes called the degrees of separation between A and B. What is the degree of separation between Carl and Yuri? So here is Carl and here is Yuri. So we have Moku in between. And so we have 2 degrees of separation. So we have, as again, Carl to Moku, Moku to Yuri. I hope this is helpful.